Welcome to Lesson 3.2's partner video. I'm going to start this video off with a little spoiler, that answer to one of the final questions in our previous lesson, Lesson 3.1. Mostly, I just want to really make sure y'all have the right function put together so that you can actually move forward in this lesson's exercises, because you're going to need it. I also want to make sure y'all are comfortable and able to map over this function across multiple park units. So we're going to go ahead and do that. So the first thing we're going to need is to create a vector of our park units that we want to map over. I am going to call that just parks. And what parks do we want to do? So many parks. Let's do Rocky Mountain. Let's do Teddy Roosevelt National Park. What else is a unit code I know? Let's do Death Valley. So now that we have our vector here, let's map over it. Let's call this object unit data. So the first thing we're going to supply it is our parks vector. Then we'll pipe that. Next, we're gonna put our map function together. So the first piece that we need to put in there is the tilde to let the map know that we want to map over our parks vector. After that, we provide it the function we want to map over, which is going to be this unit visitation. The unit visitations arguments up there are park, so the park we want to use is in fact our park vector. So we're going to put that period there to let this map know that we're going to not only be iterating over parks, but using that parks vector as one of the arguments in our function. Next, we have to provide it start year. For the sake of this lesson, let's just do 2011. And then we need to provide it the end year, which let's just have that be 2020. So remember, in this function here, we set our defaults to the starting month of January and the end month of December, so that when we run this unit visitation without filling out these defaults, it will automatically pull all of that data from January through December. So then our last step is going to be just to bind the rows of all of this data together, so we end up with just one data set. So let's see what happens when we run all of this. I'm just going to start from the top here. We're going to load our packages in. We're going to load in our function that we created. We're going to provide a vector of park units, and then the moment of truth. What does this look like? So let's see what our unit data looks like. We've got Rocky Mountain there, we've got Teddy Roosevelt, and we've got Death Valley. Okay, so it looks like it worked. And we have all of those years of data that we need as well. Oh, one other side note, I don't think I've mentioned this previously, but when you load in functions in your R console here, you actually get to see what that function is in the environment by clicking on it. So if you have a function way upstream or you forgot what that function did, you can just click on it here and it will show you the contents of it, so under the hood view. But moving back to our code at hand, we are now all starting on the right foot with this lesson. So let's walk through a few concepts in this workflow that might need some extra explaining. First, we're going to be using a new technique in this lesson called pivoting. Pivoting is a way of essentially manipulating a data frame by changing its structure or layout. So for example, in our park unit visitation data frame we just created, I'll open that up again, but we have one row for each park for each month of the year, right? So in other words, we have multiple rows that list the same month year, right? Because we have duplicate rows with the same data, we call this a narrow data frame or a long data frame. The flip side of a narrow data frame is a wide data frame. Looking at this data table here, let's think about this as having one row per month year with each park's corresponding visitation data in its own. We can make that transformation on our current narrow version of the Park Service data right here into a wide data frame by using the function pivot wider. So let's go ahead and do that. We are going to call it, how about unit wide. We're going to want to perform this pivot wider function on our unit data. So we're going to first actually select the columns within the table that we want to keep essentially when we end up transforming it. So in this instance, we're going to use dplyr select, and we're going to list the month, the year, the unit code, and then we're going to want to perform this on, let's see, I believe there's two visitor columns. There are. I think we're going to be just interested in recreation visitors. So I'm going to select this recreation visitors column to perform this pivot wide on. Once we've selected the columns we want to preserve, or the data within those columns we want to preserve, we can perform the pivot itself by using pivot wider. We'll throw in the period there to let pivot wider know we want to perform this on the piped data set. And we want, this is where the arguments come in. As you can see as I'm hovering here, there's a lot of them, but the two most important ones to me, and the ones that I pretty much exclusively use, are the names from argument. Names from. So this argument essentially tells the pivot wider what columns you want to get the names from. So what columns we want to get the names from? Well, we want each park unit to have its own column. So we're going to use the unit code column to create the names for our new columns. The next one is the values from, kind of that same thing, where what column in the data set are we going to use to fill in our new park specific columns. So we're going to want that to be our recreation visitors column, if I could only spell. And that's all she wrote. What we're going to see now when we open up our unit wide is now for every month and year, we have that visitation data for each of our 3 parks now split into their own columns, meaning we now aren't going to have duplicate January 2011 rows in here. There's just one filled in, with those park units. Now let's try to retransform this back into a narrow data frame. So basically the same data frame that it was before by using the pivot longer function. So let's call this object unit long. Oop. My goodness. We want to manipulate our unit wide data frame. We're going to use pivot longer in this instance. The first thing we want to let it know is what columns we actually want to perform this pivot longer on. In this instance, I'm going to actually kind of do the reverse of that, which is the columns I don't want to become long. And that's going to be our month column, which I think I can do that to say I explicitly don't want the month and the year by putting that the minus sign in front of the concatenate function. I think ultimately tells it these are the two things we do not want. And then instead of names from here, it's going to be names to, essentially asking, since we're going to be putting all of these columns into one column, what do you want to name that column? Let's call it park unit. Or how about unit code like it was originally? And then the values to, let's call that recreation visitors. Let's go ahead and run that. And that's always a good sign. We have the same number of observations now as our original data set. But essentially this is what it was before, right? Where we have for every park unit its own separate row, meaning now we have these duplicate month years. So that's all I'm going to say about pivoting, but now I want to go over one minor yet very useful hint to one of the exercises, but I'm not going to tell you which one, but it should be pretty clear when you get to it, and that hint is how to mutate the same action across multiple columns with just one line of code. And with this demo, we are going to need to actually get back to our unit-wide data frame, and I'm going to need to come up with something we need to do to mutate across all of these things. Okay, so after a little thinking here, we just found out that invisible aliens have been visiting Rocky Mountain, Teddy Roosevelt, and Death Valley for every month and every year since the year 1980, okay? But because they're invisible, they haven't been included in these visitor counts, so we're gonna need to add them back in. So how can we do this? We could theoretically just mutate across all three of these columns separately. So for instance, Romo plus, did I say the number yet? Let's say 70 plus Teddy Roosevelt plus 70, Death Valley plus 70. But that's, it could get pretty annoying to have to do that if we had, say, 20 extra park units that we needed to do this across, right? So one sophisticated way of not having to mutate each one separately is to use this mutate at function. So let's get back into our R script here. Let's call this new alien object unit alien. We're going to start off with our unit wide data set. Oops, unit wide. Pipe it into mutate at. The syntax for mutate at is a little strange. So it starts off with .vars. This is the argument where we tell it what columns we want to mutate across. We want to mutate across the columns Rocky Mountain, Romo, Teddy Roosevelt, and so on. Or I guess I can just write it out here. But we actually don't need to write all of this out because we have this vector already created, right? It's called parks. So to save ourselves some coding in the future, if you know you have that string somewhere, just plop that in. The next argument is .funds. This argument is where we tell it what function or action we want to perform on our columns that we selected. So the syntax here is tilde, and then what I like to do is put the action I want to perform in parentheses. So we want to perform, I said 70, I think. So we use the period to let the function know we want to perform this on our piped data set. So period plus 70, our 70 aliens. We can run that. Let's look at it. And what we have here is an updated data frame where all of our 70 aliens have been added across each park. So we can just quickly kind of give it a one over with our eyes, and yes, in fact, 70 has been added to all 3 of our columns. And that completes my video for lesson 3.2.